Look all around. Our society is driven by numbers. Tables and graphs, exam scores, survey results, speed limits, they're everywhere. Environmental trends, public policies, financial matters, healthcare decisions, and of course, science news. Numbers describe how the world works, but many of us are poorly skilled with numbers and are even afraid of them. Welcome to CU Science Update. I'm your host, Priscilla Carlson. Numbers add precision to our thinking. They help us grasp complex phenomena, sort through vast amounts of information, and discover patterns of relationships that are not easily intuitive. The ability to understand and work with numbers is a proficiency called numeracy. But when people have poor skills with numbers, they have what is called innumeracy, or quantitative illiteracy, which, sadly, is becoming a trend in the United States, where we find math and science students paralyzed with the fear of being wrong. Best-selling author and theoretical physicist Brian Greene spoke passionately about how we have educated the curiosity out of our math and science students.
You know, and I think a story that really captures this childlike spirit of exploration is one that Ken Robinson tells. You perhaps have already heard it, but it's worthwhile recounting them. A second grade class. The kids are all drawing pictures. The teacher goes over to one girl and says, "What are you drawing?" And the girl shoots back, "I'm drawing the face of God." Teacher says, "Well, how do you do that? No one knows what God looks like." And she says, "In a minute they will." This is how we begin life. But so quickly, many of us lose that unabashed, uninhibited desire to explore. We become afraid of being wrong. We become intimidated by math and science. Even worse, we begin to think of science as a drag.
Science, technology, engineering, and mathematics education in America is on the decline. This trend could be the result of an educational method that is used routinely in American schools. Rote learning, cramming. A quick memorization of information that is then regurgitated during exams, like memorizing key historical dates or state capitals or formulas in math and science classes. According to critics, rote learning of information doesn't automatically lead to understanding that information, nor does it generate much excitement in mathematics and science. Newer curriculum standards are recommending that instead of learning how to memorize names, places, and dates, students are being encouraged to embrace their intellectual curiosity and apply critical thinking to real-world experiences. For example, programs like the National Ocean Science Bowl are taking students beyond the textbook, helping them to feel engaged and excited for math and science.
Technology. The thermal gradient of the ocean can be used by humans for what purposes?
Using buzzers, toss-up, and essay-type questions, the National Ocean Science Bowl challenges high school students on their knowledge and awareness of the oceans.
Time, pencils down.
In February 2011, the Cooperative Institute for Research in Environmental Sciences at the University of Colorado coordinated one of the many regional NOSB competitions, named according to some characteristic of the region. At CU, it was the Drought Bowl, bringing together high schoolers from Utah, Colorado, Kansas, Nebraska, South Dakota, and Wyoming.
Correct.
Even in landlocked states, people often forget that oceans impact our weather, food, and medicines.
The oceans are such an important part of our daily lives, and particularly in a state like Colorado, which is landlocked, people forget how much of our life is impacted by the ocean. So we need for students to be aware that everything that happens in our daily lives is impacted. Our weather, the food that we eat, medicines. We have to care for the oceans, and without having this knowledge, we don't have an ocean literate population. And the high school students are where we need to start to help them get excited about the oceans and care about science just in general. So whether or not they become an ocean scientist or they become a lawyer, if they're they're literate in the sciences and understand the importance of whether it's land-based or ocean-based, we end up with a better society in the future.
The keynote speaker of the event, Bruce STRICKROTT, an expedition leader and pilot for the deep submergence vehicle Alvin, shared his personal experiences with the students, bridging the gap between textbook and the real world.
People have a particular ideology, as an opinion of how important a particular thing is, particularly when they're kids. If they're connected with the idea that ocean health is a big deal, and they leave here and head off to schools and study and bring that sort of ideology that this is an important thing, then it certainly has the potential to have long-term positive impact on things. The main thing is that has to be nurtured outside of this environment. This is a very small group of people very dedicated to making this happen. When they step onto a university, they have to find a nurturing environment within whatever they study, particularly if it's science.
School programs and club activities can encourage a passion for learning. Sometimes it just takes getting involved, as students and teachers realized when they joined the National Ocean Science Bowl.
Actually, I've never really been that interested in sciences. I just joined because my friends were on it and they wanted me to join. But now that I've started, it's really interesting learning about everything in the ocean. I think it's opened up a lot more opportunities for me.
It's less about the ocean than about the world, I've learned in, like kind of Ocean Science Bowl, because it's like the ocean is it's kind of a broad topic, but they go way beyond.
One, I love the subject of science, and also just being able to tell kids about that and transfer, what I know and what I love, kind of my passion, have these kids get excited about it. It's just probably the best job there is.
We actually have a longitudinal study, and it's been going on. We're in our 5th year of the program, and we're tracking students that have gone through NOSB, trying to determine, is the program impacting their desire to go into the sciences and specifically into the ocean sciences, and we are seeing really positive trends. Many of the students say because of their involvement in NOSB, it actually drove their decision to major in a science, and particularly in an ocean science. About 70% of the kids now are taking more science classes in college. About 60% of them say because of their participation in NOSB, they're looking at majoring in a science, and about 38% of them are interested in participating in a career in the ocean sciences.
The 2011 Trout Bowl winner was Poudre Valley High School. Well done. In April, they went to Galveston, Texas for the national competition, but were beat by this year's champions, Wisconsin's Marshfield High School. Interactive programs like the National Ocean Science Bowl can help take the fear out of science learning. But not all learning opportunities are the same. The United States is lagging behind other nations in the instruction of science. But is there a way to reverse that trend? Joining us in the studio is Sanjoy Mahajan, who is known internationally for his work in improving mathematics and science learning. A PhD in theoretical physics, Mahajan has undergraduate degrees in mathematics from Oxford University and physics from Stanford University. His interest in science teaching grew while on the faculty at the Massachusetts Institute of Technology, where he became an associate director of the Teaching and Learning Laboratory. His book, Street Fighting Mathematics, The Art of Educated Guessing and Opportunistic Problem Solving, was published in March 2010. We are delighted to have him join us straight from his panel discussions at CU's Conference on World Affairs. He meets with our correspondent, Rose Heaphy, who begins the interview with the all-important question.
Should people be afraid of math?
No, but the education system produces that because the teaching is so abysmal. And the focus on right answers actually produces fear in people that, oh, what if I don't get the right answer? Then people will find out that actually I'm dumb, or I'm going to get put in the wrong class or not get into Harvard, or who knows what tragedy may happen. So it actually produces fear in people, and that fear produces paralysis. And then people are blamed for it. Said, oh, well, I guess you just weren't good at math. Not everyone can be good at math. And so that's just blaming the victim. So yeah, people shouldn't be afraid of math, but I can see why they are, given the way that it's taught. And so that's why I'd like to have the teaching improved, or so that people actually come out curious and engaged with mathematics.
Definitely. And now you're kind of talking about how the process should be the greater focus. Now, in your book, Street Fighting Mathematics, you're kind of describing like a down and dirty style to problem solving, educated guessing. Explain that a little bit for us.
Well, in mathematics is considered the most precise of all the, say, sciences, if you call it a science, it's the most precise language, and students are taught over and over, oh, you must be, make your proofs clear and make them rigorous, and rigor, they're told. But what I tell my students is, well, rigor, yeah, that's nice, but rigor leads to rigor mortis. And that's exactly what it produces. The students, people are so worried that they might have the wrong answer, they're not even willing to try something which may lead them to a right answer or to an interesting conclusion. So the down and dirty problem solving, the idea is just try something. It may work, it may not, but you may learn something, and then you can try something else. And you may find that with a quick, crude estimate that your whole idea you realize right away is a complete waste of time, and you can try something else, rather than spending a week on it, precisely finding the answer and then saying, oh, whoops, I need to do something else. So as the statistician John Tukey said, it's better to be approximately right than exactly wrong.
Definitely. So is this something, so basically, that everyone can use and not just mathematicians? I mean, people, obviously aren't using the highest levels of math in their daily life, but this kind of just working out this process and problem solving, how can people, the layman's person, use this process?
Oh, all the time. So for example, in understanding all the numbers that are thrown at you in the media by the government, by corporations. For example, during the oil spill, the Gulf Horizon spill, people were told, well, there's we're told at first there's 5,000 barrels. And then people were told, oh, well, actually it's 210,000 gallons a day being spilt into the Gulf. Now, if people understand math, they can actually start to question that. And you say, oh, where did that 210,000 come from? Oh, that's because it's 42 gallons per barrel. And so they just took 5,000, multiplied by 42, and converted 5,000 barrels to 210,000 gallons. But the problem with that, reporting it as 210,000 barrels, is it gives it an air of precision that 5,000 barrels doesn't have, because it has a 2 and the 1 in the 210,000. So it seems like, well, okay, it could be 220,000, it could be 200,000, but it's not going to be much different. They must know something about it. Whereas when they say 5,000, you're like, yeah, okay, 5,000 could be 6,000, maybe 7, maybe 3. It seems they don't know much. So the way things are reported can influence how you perceive these. And if you understand numbers, you actually have control of that. And you're not just subject to that. And it turned out that, in fact, they didn't know very much. And the 210,000 was complete fiction writing. And even the 5,000 was completely wrong, too. Maybe it was more like 10 or 15 or 20. No one knows for sure. But certainly reporting at 210,000 was completely bogus. And someone with what I like to call insight into numbers, wouldn't be fooled with that, and actually can start to say, well, I wonder why are they saying that it's so precise?
So it's definitely important to have that media literacy.
Yeah, intellectual self-defense.
Definitely.
Quantitative self-defense.
And then now your current mission right now is to for the transformation of the engineering education. Now,
yeah, engineering and science.
Engineering. Yeah. So, what about the engineering and science? What needs to be fixed right now?
Oh, the whole thing needs to be upended. It's just a shambles. It's just abysmal. So it starts in school and continues all the way through university. That the main problem is that students learn everything by rote. So they are like parrots. Parrots can say lots of stuff. Mm-hmm. They can say amazing things. They can say whole sentences, but they actually don't understand anything they're doing. And as long as you test them on just those sentences, they seem like they know a lot of stuff. And so there's been kind of a tacit agreement. Look, we'll just give you stuff to memorize, and we'll promise to test you only on those things, and we can all call it learning. And so that's what happens. An example of that is there was a study this was in 1977, a study of the Second National Assessment of Educational Progress. They gave students the following question on fractions. They said, estimate the sum of 12/13 plus 7/8. And they gave them 4 choices, or 5. 1, they told them you don't have enough time to do it all fully with pencil and paper, multiplying all the denominators and cross-multiplying. Mm-hmm. So just estimate it. They gave them 1, they gave them 2, they gave them 19, which is the sum of the numerators, and 21, which is the sum of the denominators. Among the 13-year-olds, 24% picked 2, which is the correct answer. And among the 17-year-olds, only 37% picked 2. But on the same test, they were given actual fraction problems to actually compute exactly. They didn't have really any problem with that. So
but are you saying basically even that huge gap in age where they should have been able to...
Well, by age 13 even, they should have understood that if you take a fraction that was roughly 1 and you add another fraction that's roughly 1 to it, you're going to get 2, roughly. You're not going to get 1. You're certainly not going to get 19 or 21. But if you don't have any understanding of what's going on and you just pattern match, you say, oh, okay, fractions. Well, I have to do stuff with denominators and numerators, and I don't really actually understand it. Well, then you're not actually learning it. You haven't learned anything. So at age 13, they didn't know anything about fractions, even though they start them, I don't know, age 6, 7, 8. Age 17, they didn't know anything about fractions either. And how are you going to build scientific understanding on top of that level of quantitative illiteracy, which is what's produced by the schools?
So in the public school system, K through 12, what needs to be done so that they can be prepared for the higher education learning?
Well, so before I answer that, I'll say the higher education doesn't help much either, and it's part of the problem. So in higher education, you just do more rote learning, where you just memorize even more complicated stuff. And we filter for people who are really good at memorizing stuff they don't understand. We say, okay, you're a really good student. You can take really hard classes, where we give them even more stuff to memorize. So the reason I bring that up is that's part of the problem, is that's where the teachers are taught. So the way to help their early education would be to have teachers who actually understand mathematics really well, like other countries do. But in America, it's, for example, not required to understand or take any mathematics to be an elementary teacher. And I mean, in high school, yeah, but in elementary school. So, and mathematics, with all the teaching that we see in mathematics, it produces a fear of mathematics among people who are now going to be teaching mathematics. And from child raising, I know that children are really sensitive to adults' emotions and implicit feelings. So, for example, if I'm upset or annoyed about something, my daughter will right away notice it and say something. Well, you can imagine if you have a teacher who's afraid of math for a whole year or years and years and years, what that's going to do to the students. So the best thing, I think, would be to have teachers who are curious and love mathematics, who want to share that love with students. But that means the whole education system needs to change, because higher education needs to help trying to produce more of these kind of people. And our society needs to change such that teachers are valued. And so people who have those kind of abilities and skills will say, oh yeah, I want to go into teaching, rather than saying, no, I don't think I want to go into teaching because I'm just going to spend my whole time teaching to these ridiculous high-stakes tests, which have nothing to do with mathematics whatsoever.
Now, as you said, a lot is put on the teachers and the kind of the curriculum and the way that they teach. Is there anything that students can do where they can kind of get a better grasp on mathematics and science?
Yeah, they'll have to just ignore all the tests that go on in schools, because those tests have really nothing to do with mathematics. They're labeled mathematics and they have things with numbers in them, but they don't teach you any kind of reasoning that actually helps you understand the quantitative world. So the best thing to do is to go out and estimate. So every time you see something, you think, how could I have got that number? Is that reasonable? Like, for example, how much oil does the U.S. import? Suppose you see figures about oil imports and flows and who has oil reserves. And high school students can be reading the paper and start to wonder, well, does that number of barrels per year seem reasonable? I wonder what it should be. Well, let me try breaking it up into parts. Okay, where's all the oil used? Let's say it's used in cars, and then a bunch of other uses. So let me just estimate the cars to start with. How much does each car drive? Okay, I know how much either my car or my parents' car drives. Let's say 10, 15,000 miles a year. How many miles per gallon do they get? Oh, I don't know. Let's say 25 miles per gallon. So we're now talking something like 400 gallons per year. So now how many barrels is that? Roughly 10, maybe. And how many cars are there? Roughly 1 per person, so about 300 million. So maybe there's about 10 barrels per person times 3 per car, and there's 300 million cars. So about 3 billion barrels a year, U.S. imports, let's say, or U.S. oil consumption for cars, and let's say that's roughly the imports. Okay, well, that article just said it was 1 trillion. That must be total nonsense. Or, it's saying it's 2.5. Okay, yeah, that makes sense to me. Then they're starting to make connections among all the other numbers. It turns out the actual figure is 3.7 billion. So that estimate actually is quite reliable. So that way of looking at the world, saying, well, how could I figure this out for myself? You can do it, and you just have to free yourself from the idea that you have to be exact. Just start estimating, try something. Like, well, I don't know, how much does each car drive? Well, yeah, I don't own a car, but I know people who have cars, and what do? They go to work with it. Okay, how much do they drive each day going back and forth to work? And just estimate that. You can always do something. That's the street fighting approach.
So basically students need to go back to being critical thinkers.
Critical thinkers, creative, critical, questioning, inventive thinkers, yeah. And the tools that people learn in school stifle that.
Definitely.
And the idea that you have to be right or you'll be punished, that produces a kind of fear that means you'll never do it.
And now, kind of taking back, now looking at, we're at the higher education, what can universities do to promote diversity within their own schools? Like, for example, at our School of Journalism, there's under 20% of women in the program, and underrepresented minorities is under 10%. And these figures are from 2006. How can they extend to these minority groups?
Well, for example, in science and mathematics, well, I think one of the pieces of conclusions I draw from the fact that, say, there's so few women in, say, mathematics and science is that women are smarter than men. They say, the teaching is crap, get me out of here. It's just one random fact after another, or one random proof of something that's either obvious or ridiculous. There's better things to do with one's life.
It's good for Jeopardy, but how does it apply?
Yeah, how does it apply, and is it really helping me understand the world? No, it's just rote learning. So I think women are, in that way, more intelligent than the men. And so I think the way to improve it to ratios and get more women into science and math is to actually improve how science and math are taught. So, for example, history. What's the story? Why did people ever develop the Pythagorean theorem? What kind of problems were they working on? What were they building? What were they trying to understand? What was it about the universe? Was it about architecture? What was it? Okay, if it can be seen as part of a story, it helps everyone. Because things that are part of stories, one remembers much more, and because it's connected, and that's how humans learn. We're language-using creatures. But also, I think women are in that way also more intelligent. They say, well, if it has some meaning and sense, then I'll be interested in it. But I'm going to wait until then. So let's put some meaning in with stories.
It's basically make it become more than just a triangle and trying to find and using the hypotenuse and
right.
Squares.
Yeah, put in the social context. Why did people care about triangles? Were they building something that was a triangle? Or did someone, clearly someone didn't just say, there's a triangle there that has a right angle. I wonder what the relationship between those two sides and this third side is. No, nothing happened like that. And it would be really good to actually show students how is it that mathematical ideas develop? What kind of social soil do they grow from? To show that mathematics is a human subject too. And that would be very good for the democracy as well, because people would see, oh, mathematics is a human subject. That means just because someone has a number, it's not God-given, ordained from something higher. So if someone uses a number, it's not that they have some access to this mystical power. It's as a result of a human process, and humans can critique it, which is what you need for an informed citizenry.
And then what about the minorities who who sometimes go to some of the worst public school systems? How do we get them into the higher education?
Well, improve their schools. So stop the testing. The testing is it's abysmal. I wouldn't say it's a disaster, because a disaster sort of implies that it's not doing what it's supposed to do. I think it's doing exactly what it's supposed to do, which is dumb down the education and make people sheep. So people have to stop it. Because basically what the test measure is what's the average income of the parents of the children in the school. And then you punish the schools where the average income is lower. It's a good way to punish schools and take away professional skills from teachers, saying, well, you must teach to these tests, which makes education even worse, which makes it, it's then a much better way of having a sheep-like population. But people need to stop that. Stop the testing. Instead of testing people and saying, well, if you test this or that, we'll give you some money. Say, look, all the schools that the wealthy people go to, they are very well funded. Let's fund you that well too. Like New Jersey does that to some extent. There was a lawsuit, civil rights lawsuit, saying the way schools are funded is completely unconstitutional because it's funded by property taxes. And so the rich areas, those local towns, have a lot more money, and the poor areas like Camden and Trenton have almost no money, and there's such a huge disparity as to be unconstitutional. And the New Jersey courts, I think the New Jersey Supreme Court agreed and said, okay, the state actually has to, from state revenues, which I guess is income taxes and to some extent maybe sales taxes, has to be used to equalize the funding across the districts. So things like that really need to happen.
Definitely. And then some kind of final words. How can students be those street fighters? Just some last words on that.
Take nothing for granted, question everything, and think to yourself, there must be a way that I can understand that or improve it. Let me figure it out. And don't ever believe anyone who says that intelligence is a thing that you're born with. Intelligence is a matter of attitude and how you approach the world.
You might think it's no different from nitpicking, but critical thinking is an essential skill that allows us to analyze any subject. And to master it takes practice, regular practice. And that practice needs to begin in school. That's it for this edition of CU Science Update, and it's the last in our series of guests who participated in CU's 63rd Annual Conference on World Affairs. We are grateful to the conference organizers and to the guests who joined us for some fascinating topics. Look for new shows coming soon where we continue to visit the scientific community in Boulder. In the meantime, you can download previous episodes from iTunes or from our website at cuscienceupdate.com. And don't forget to like us on our Facebook page where we post the latest science news from Boulder and beyond.